Okay, so seems we're good to go. Welcome everybody. I hope you enjoyed the conference so far. We're about to have lunch right after this session, so I'll try to stay in time for this presentation, so that each and every of you can grab lunch afterwards and nobody has to stay hungry. What we're gonna do is we're gonna talk about a little bit about Reactive, Spring Data, this whole Spring ecosystem. And for a little introduction to myself, my name is Christoph Strobl. I work for Pivotal Software, which is basically the host for Spring development or most of the Spring team and the ecosystem projects such as Spring Data. So I myself work within the Spring Data team, and I'm mainly responsible for the store abstractions around MongoDB, Redis, a little bit of Solr and stuff. I also do JPA from time to time, though I must admit I like the NoSQL store a little bit more because there is more recent development happening. Okay, so much for myself. To get started with Reactive, I want to start with a quote from a colleague of mine, actually from Russen, who defined Reactive and reactive programming as such as it is about non-blocking event-driven applications that scale very well with a small number of threads. And the one thing he stresses is that backpressure is a key ingredient to the reactive programming world, as it makes sure that a fast producer doesn't just pipe out stuff to a potentially slow consumer that can't handle that amount of data. We'll see what it means a little bit later, but this is something I really want to share with you because I think it's a very, very good quote of him. What we're going to do in the next 50 minutes or so is we're going to have a look at the more recent history. So what happened the, let's say, past 2 years within the Spring ecosystem? What did we do to support the reactive programming and functional programming model? We're going to have a look at Project Reactor as the framework of choice or reactive composition library that we in the Spring framework and in the ecosystem projects are using to move forward with the reactive story. We're going to have a look at Spring Data in particular and the reactive support in there for several stores that have reactive drivers. And of course, we're going to do a little bit of Spring Framework 5 as well, as it's the foundation for all the stuff we're doing. And in the end, I'm going to show you some code so that you actually get a feeling how you can put that stuff to use in your everyday applications and code. Okay, let's start off with a little bit of recent history. Of course, the history of reactive programming goes way back to the Sum.NET world. But for us, it mainly started during Spring 1 platform in September 2015, where we as a team actually got together and thought about the reactive story that we're going to deliver over the next couple of years and that is here to stay. So that was basically more or less the beginning for the reactive story within Spring Framework itself. It took about a little bit more than half a year to get some first milestones out. So we had Spring Framework 5 and 1 in July, followed by a Reactor release a little bit later, as well as an early milestone of the Spring Data Access layer that already delivered an early stages of reactive data access based on Reactor 3.0 back those days. As we moved along, basically more recently this year, we had the Java 9 release actually. Reactor 3.1 went GA. There have been quite a bunch of breaking changes within the API as we incorporated the project more and more or put it to use more and more within the Spring ecosystem. So Reactor 3.1 is a huge milestone with a stable API now. This won't change for the next couple of years. Then we got finally Spring Framework 5 GA, huge step forward for us as we just basically rose the baseline Java JDK requirements to Java 8 and above, fully compliant with Java 9 already. And just a little later, we also released the first first GA release of the Spring Data Key release train that offers reactive data access in a release version, obviously. And of course, today also a very special day. It's JavaDay Ukraine 2017. I'm really happy to be here and tell you about all the stuff that we did over basically this period of time. And a little outlook to the future. I guess everyone's waiting for the Boot 2.0 release, hopefully happening this year. There is no fixed date yet. To pick up basically all the stuff that we did in a curated way. Perfect. By the way, there's a sneak peek on Boot 2.0 later today by Stefan. Make sure to definitely check out that presentation. Okay, so before we jump into more reactive stuff, let's have a look at what we've done so far, basically, with the imperative style applications. Everyone who's developed the Spring application the recent years basically is familiar with that. So it's a simple REST controller that has just a get mapping, basically that returns some JSON stream loaded from a repository. So it basically returns a list and renders a JSON to whatever HTTP endpoint. So this is pretty familiar. I guess everyone's done that, and basically you're in total control of the flow. So basically you got your boot applications, there comes a request, you basically sometimes may end up talking to a slow store, retrieving some data, then going to maybe another faster store, retrieving additional data, and then basically returning the stuff to the client. So this all happens within the thread normally, and you just have to go through the processing steps one by one and just gather all the results and return it to your client. So this can be time consuming, and as everyone knows, with the increasing number of threads, you will have threads stacking up, potentially waiting for some data source and all that stuff, and this can all be costly and timely, and potentially you'll reach the limit of threads that you're able to use, and your application will become irresponsive at some point. So this can happen to you, and what we did basically the past years to cope with those scenarios is we started batching stuff up. So basically we just batched up calls to a slow data source to just retrieve more, because we know the connection and stuff would take longer, so we retrieved a bit more data and just to get the stuff through a bit faster. Or we ended up with some async commands. So we basically dispatched our need to more sources. So if you think about it, it's like moving your stuff from one flat to another. If you just move to another town or just to another flat, and you just, in the one side, you just walk around on your own, you carry stuff from one place to the other. Takes a lot of time. If you batching, you take just more stuff, not one item at a time, so you're more efficient, or you invite some friends that do the work for you, but you still aren't done till you fetched everything. So this is basically what happens here. And you, of course, need a dispatch and all that stuff, so you get overhead in the processing stuff. Okay, for reactive, now we're jumping into the topic a bit more. For reactive, we basically get to take a step back and look at the problem from a meta level in first place. So what we want to talk about when we're talking about reactive is we're talking about a publisher and a subscriber. So publisher is something that pushes out stuff, and the subscriber is the one who wants to receive stuff from the publisher. And basically the subscriber goes to the publisher and subscribes to it and says, hey, I'm here, I want your data or whatever you have to give me. And the publisher returns a continuous stream of elements to the subscriber. So this is the idea behind the reactive story. And of course, we have a knob in there, a volume control, so to speak. This is the backpressure. So the subscriber can signal to the publisher, I may take one item at a time, or give me 10 at a time, or give me the next 10 items and then please stop. So this is backpressure. So the client can signal to the publisher, basically, don't give me too much. I currently cannot handle more data than I request. Good. So what you need to remember when talking about the reactive stuff, and this is important for me that you at least take away from this session, is that we are moving from a pull principle in the imperative world. So we got iterator next or future that get. So we are going there to the iterator or the future explicitly and request data by saying, give me the next element or get me the result of the future. Versus in the reactive world, we get the data handed to us. So this is a push principle, because we basically ask the publisher to give us the element as soon as it's there. And basically the publisher calls the onNext method on the subscriber. So whenever data becomes available through the publisher, it's basically handed to the subscriber, to us to do something with it, or just ignore it if we're just not interested in it anymore. But that's the thing we have to remember, and that's the paradigm shift that we have in our thinking and minds that we have to do. Okay. Let's have a look at Reactor 3.1, and to do so, we have to first start off with the Reactive Streams specification. So Reactive Streams is basically about 4 interfaces that define how a reactive processing chain works together. So it's 4 interfaces in the TCK for all the implementations out there. And basically it defines a publisher that provides an unbounded number of elements. So it can be 0 elements, it can be 1, or it can be an infinite stream, just continuously emitting elements. We got the subscriber, so the one that receives basically those elements. And we got the handshake in between those two. This is the subscription. We'll dive into that a little bit more later, but this is basically the handshake between the publisher and the subscriber, working all the life cycle. And of course, there is a bunch of processors or processing stages that allow you to manipulate data and so forth. For Project Reactor, we got 2 main types. Actually, there's only 2 types for Reactor that you will have to deal with, and those are based on Reactive Streams and the Reactive Streams specifications. So a Flux is basically a publisher. Though a Flux gives you more context, because a Flux is defined as 0 or n elements. So it's basically a stream of multiple elements. Whereas there is another type that is called a mono, which is defined as 0 or exactly 1 element. And what this means is it allows you to add more context to your method signatures, because as you can see there, find all by last name returns a Flux. So it is obvious from the method signature that there will be potentially more than 1 element or 1 person with the same last name, obviously. While on the other hand, find by email address. Email addresses are supposed to be unique, so it gives you either 1 or 0 persons with that special email address. So this is, in our opinion, a huge advantage, because you can tell from the method signature what to expect from the method. And if you're wondering why it's called Flux and so on, I mean, mono is an obvious choice, because it's just for 0. Flux is actually a flow by definition. And if you now look at the alignment of those, then you see that basically with the generic types, first of all, the Flux and mono both have 4 letters, so it basically aligns very nicely with the generic types. And if you're using the generic types, it also aligns nicely the method names down, so that the eye isn't irritated while basically reading through the code or interface definitions and whatnot. And this is actually something that we in the Spring team call Jürgenized, and this is a true story. So there has been a long back and forth on the names, and this is what we've come up with, and thank you, Jürgen, for that. It's really a great effort. Okay, let's jump into reactive applications with Spring and what our goal basically was. And this was to provide you with familiar concepts of expressing new functionality with a minimal amount of surprise, actually. So this is what Spring is all about. So we want to make your life a bit easier without surprising you too much. So when you have a look at Spring Web Flux, then, and this is a REST controller, and we have a get mapping in there, and we got a repository and all that stuff. This pretty much looks like, I've seen this before, ain't I? I mean, this looks like the imperative stuff. Still it isn't, because the important stuff is done here. So we got a flux of persons, and we got a reactive repository that returns us a flux, but we still can just hand out the flux as we used to do with the imperatives coding approach. So this feels more or less the same, though it does completely different things under the hood, actually, because we moved to the reactive programming approach already, just by defining our controller this way, just using another jar for it. And if we basically step into the repository, then we encountered that this is not any longer just a CRUD repository, but a reactive CRUD repository. It feels exactly the same as the imperative counterpart, and though it works internally a little bit different, though still the same principles apply, more or less. So basically, you can define a Spring Data lookup method that derives the query from the method name, and instead of a list, as you would in the imperative world, you just return a flux. So this basically just executes a query in a reactive way and just gives you a publisher, more or less, because this is a flux. Of course, in the Spring Data world, we also allow you to have more derived execution, so you could also hand in a mono of something into the finder method so that it gets executed when the mono is available and just returns this stuff later on. And of course, you can do all the things that you've been used to using with the imperative style. So you can define your query methods in there, and they will get resolved and executed just the way you would expect them to do. With one difference. In the imperative repository, when you define basically a pageable, you would expect to get a page in return. So basically, you define the offset you want to read from. So starting at position 10 to let's say 20, and you'd get in return a page for exactly that range plus the next page and has the previous page and whatnot. And we explicitly decided to not have something like a reactive page and introduce a new concept, but rather just return you a flux for that range. So the pageable here is just to pass on potential offset parameters and sorting parameters down to the reactive driver so that they get applied on database level, actually. And you can then use the control mechanisms that you have on the flux to just retrieve the next page and do continuous loading and what you want to do. Great. So this is the query derivation that you can do and the options you have with the reactive CRUD repository. Of course, there is on the repository itself, the definition, there is methods like save an entity in a deferred way, just returning a mono, or saving a mono of an entity, or fluxes, publishers, whatnot. So these are all the methods that you might already know from the imperative repository. You'll find the exact counterparts just with the reactive type signatures on the reactive repository, and this of course goes on for exists by ID, giving you a mono of Boolean, or find all with a flux and count and whatnot. So no surprise actually in there, or hopefully in there. If there are big surprises, please raise your hand and we did something wrong. Okay, moving a bit one level down, we get the reactive template. So if you're familiar with Spring and the templating stuff, this is just a template for MongoDB, in this case, a reactive one. So what we got there is the obvious methods pretty close to the reactive driver. So we got a find one, actually returning a reactor type, or of course, let's say a find all that takes a class that should be mapped to and the collection name, and then we just go there. Under the hood, we're of course using the Reactive Streams MongoDB Java driver. In case of MongoDB, for Redis there is others. There's Leddish that offers a Reactive API. So basically, what we do is we build upon existing reactive drivers. So we don't build the reactive driver ourselves, but we just rely on the drivers out there and adapt to the programming model that we want to expose. Okay, so we got the Reactive Streams MongoDB Java driver. And what you'll find in there is something called a find publisher. So MongoDB chose to go with their, based on Reactive Streams implementation of Reactive Types, basically. So this is a find publisher. It is a publisher, a generic one of some document, and you can pass in BSON filter. And of course, there's the raw publisher for longs and arbitrary values, like for count operations. And what we do is we defer the execution to the MongoDB Java driver, the reactive one, and then just on Reactor, we get convenience methods that allow us to convert from publishers into fluxes and back and so on and forth. So we basically wrap the results into a flux that then gets passed on. I'll show you a bit more of Reactor in the demo so that you can actually get a feeling what you can do with those types and why it's beneficial for us and hopefully also for you to just use Reactor types. Yeah, and under the hood, so now we are really deep in the reactive world and the reactive programming model. What happens really under the hood is we got a publisher, like the find publisher. And on the other side, we have a subscriber, so the one that requests the data. And what it does, it basically, first of all, you basically go to the publisher and say subscribe and pass in the subscriber, which then holds the methods that you what you want to do with the actual results. This produces the subscription, so the handshake element that is responsible for the whole life cycle. And once the subscription is created, the publisher calls the onSubscribe method on the subscriber, giving the subscriber the actual subscription, so the handshake, so you're in full control of it. And now, on the subscription, you can basically say, give me number of elements, so request 10 elements, 5 elements, as much as you can handle at the time. So this would be your client code, so it says, give me 3 items. This signals to the publisher to emit the next 3 items as soon as they get available. And as soon as one item gets available, it basically calls the onNext method and pushes the element to the subscriber. So this is actually how the workflow internally works for Reactive Streams, and this is what happens deep down in the MongoDB Java driver. So this is what happens, it then gets just passed on to the web layer through Spring Data, basically to Web Flux, and then eventually to your client. And of course, there's the processor that lets you manipulate data, but we'll skip that one for now. Yeah, we got about 25 minutes for some code. I prepared a little demo. I hope it's big enough for you to read. What this is basically a Spring Boot application. If you go to start.spring.io and select Spring Boot, the current milestone, 2.0 M5, this is what you'll get a skeleton, and then I just used the demo application and prepared some stuff in here. Sorry. Okay, so what we got in here is basically I prepared an array of names, some of my favorite characters from, I guess the book is pretty well known. Then I create a random, and what I do now is basically I create a flux from a stream. So I basically just use the Java 8 streams generate, pick a random name from the array I created before and turn that into a stream. And what I also do is I map it to a person. So a person is defined down below, so it just has a name and an ID. The ID gets assigned once it's stored into the database. Okay, what I'm going to do next is basically I I say Flux, and this is one of the convenience methods. So on Flux, there are several convenience methods for you, like interval. So interval takes a duration and then emits a tick, basically at every second in this case. So basically, we have a Flux that emits a 1, 2, 3, whatever, every second a tick. And now we want to combine two streams. And you can do so using the zip width method down here. So basically, this allows you, so we got a stream of ticks on this side, and we got the stream of names on this side, and now we combine the two. And as a result, I get a tuple of 2, of course, because there are 2 elements right now. I'm only interested in the second element, which would be the start, so I don't care about the tick anymore. And then I call something like flat map, which allows me to do some transformation, and I call repository save, and then I just print out the result. And this is the important part, I have to subscribe to it. If I remove that line, nothing will happen, because I never actually trigger the execution. So you have to make sure and not forget to subscribe to something. And then, okay, I print out some, winter is coming down here, because in an imperative world, if I just subscribe to an infinite stream, I would never reach that point, actually, because I would be stuck in here, which isn't the case for the reactive one. Okay, here's the reactive repository implementation, just to complete the stuff in here. So let's run this shortly. I'm using an embedded MongoDB, just in case you're wondering. So the data will be gone every time I restart my application. And as you can see, it already starts emitting persons, random persons down below. They got an ID assigned, so they are actually saved within the embedded MongoDB service. So far, so nice. And it also printed out winter is coming, so you can see this happens definitely not in the main thread, and it's not blocking our application. Good. Still, that's not very impressive, because normally you want to do something with your data. And let's say you want to expose your data to a client via a REST service, just as we did with the REST controller. Let me just check out this, because I'm really bad at typing, especially when I only got 20 minutes left. So let's go through the commits in here. This has been good. See you. Wrong window. Okay. So we changed a little bit. You can see the main method is still, or the run method is still the same. We still emit the persons. But what we have here is basically we have the REST controller that has the reactive repository in there. And what we defined is a derived finder method, find all by name. And so we can pass in an arbitrary name, and we have a get mapping defined, so we can just go to a browser and call the endpoint and then just get this stuff back. So let's do this real quick. So we're starting up the application. Window's too small down here again. And you see it starts again emitting data. So if I now call HTTP, you can also say 8080/name equals who we have here, aria. Bloop. Why is the connection refused? Oh yeah, my bad. You just have to have it here. And you can see it just emits this stuff as it comes from the database. What I want to show you now is that with this, actually, when we now start adding a delay in here, so we could say delay elements to just not have them appear rapidly, we could say delay duration of seconds 1. And this is, we give it the endpoint the name and say produces media type, and this is application stream JSON value, and this is important. If you define the media type as a JSON stream, basically, what it will do, it will instruct the Web Flux component to just send out a chunked response and emit data the time it occurs to the endpoint. So we basically delay each and every element in here and send it out later on. You'll see what I mean by this in a second. Let me just start it. Okay. You wouldn't normally add a delay by intent, but for the demo here. Okay, we got recon in here. So as I'm now consuming a stream, I have to call the stream method, and then John is there. Okay, for the first element, it waits a second, and you see it starts emitting second by second to the client. So your client can basically consume a stream of data instead of having to wait for the entire stream to be collected and then rendered as one huge JSON, but you can rather send out chunks of JSON, which lets your client react to the response more quickly, actually. Because if I remove the, let me quickly do it so that you see the difference. If I remove this JSON stream value from here, Spring Web Flux would assume that your client is interested in the in application JSON media type, which sends out the JSON as one big chunk, actually. So let me start it again. Let's wait for, there's aria, we should have at least 2 to make it work. There's addot is with 2. And you see it waits and waits, and then you basically get the 2 results immediately. So there is a huge difference in the media type you choose to the behavior that interferes to the Web Flux component. So, and what happens in there within the controller is basically once a connection gets opened to that endpoint, Spring Web Flux will automatically subscribe and unsubscribe for you once you've consumed the whole stream. So this is very, very convenient, and you don't have to actually care about the whole subscription and lifecycle stuff. So this has all been taken care of for you. Good. So moving on. This is something that's really important to me, because I don't like untested code, and I guess everyone is questioning himself how do I actually test that stuff, because it's quite different from what we normally do. And the answer is pretty easy, because git 0 and then git, not the git command. Yeah. The answer is pretty easy, because Project Reactor comes with a Reactor test jar that includes something called a StepVerifier. And the StepVerifier lets you test your reactive execution chain very easily. So basically you say StepVerifier create, give it a publisher, and then say, okay, for a repository save method, you'd expect a next count, because the repository save just returns the object save, so you'd expect the next one, and then you expect verify complete, so you expect it to not emit any more data. So you're done with the execution. Or if you, and then basically you could say repository find all by name. So since I saved an aria, I would expect to get aria back. So I take 1, so the first element, in case there might be more, and I consume it and assert that the value of the name basically equals aria. So you can just write a simple JUnit test, put in the StepVerifier, and test your reactive execution chain and what you did, the repository implementation and whatnot. So basically everything you wanted to do. You can also have convenience methods like virtual time, so that you don't have to wait for several events to occur, but just fast forward to something. There is more decent presentations on that stuff. You just have to look it up on the net. There is Josh Long and Mark Heckler who can really present that in a very decent way and tell you how to work with that stuff. But to just give you an impression that it's not that hard to actually test it, because there is tools that help you test that stuff. Good. Having said that, anyone in the room liking RxJava? No RxJava fans in here? A few there. Yeah, perfect. Okay. Git, I always forget the comment. It's pretty easy with the Web Flux component or even Spring Data to make use of RxJava type if you prefer those over the reactor types. So what we allow you to do is basically you can define within a Spring Data repository, we allow you to use RxJava types as return values. So you could define a find by name method, returning an observable, and then just pass it on throughout the Web Flux component to the client. So you're free to choose the reactive composition library of your choice, more or less. So we prefer, for us internally, Project Reactor, as we get more control, since we are contributing quite a lot of engineering hours into the project. But still, you're free to use RxJava types anyway. So this just works the same way. We're just internally using Flux and then just using a bridge method to convert it into an observable back again, because it's all reactive stream based, and so therefore pretty easy for us to do. So much for that. 30 minutes left. What I wanted to show you additionally is something that is possible only with MongoDB, and that is how to emit an infinite stream of data directly from the database to, let's say, a web endpoint. And this is pretty easy. So down on the data side, first of all, you have to create a capped collection in MongoDB. Anyone using MongoDB? Yeah, quite a few. Okay. I guess those of you already know what I'm talking about. So in MongoDB, you can basically create a capped collection and use a tailable cursor on that collection. So this is a cursor that stays open and emits data back to the client every time a document is inserted into the database. But this only works with a capped collection and the tailable cursor. So we set up the collection correctly, tell it it's capped, set max documents and size, because this is required, and use the addTailable annotation on our finder method. So this basically advises Spring Data to just use the tailable cursor underneath and then wrap the result into the flux. So this produces basically an infinite stream. And of course, I can also push that stream to an endpoint. So what I have here, that shouldn't be there, is we got an endpoint stream that produces a text event stream. So it basically pushes out servers and events by the repository.find method. Good. Let's do this. There we go. So what we're doing, we're again inserting data into the database down there. And once we now connect to the endpoint, of course we have to use the stream option. Then you see data gets pushed into the database and then by the tailable cursor pushed back out through the repository and the Web Flux layer as an event stream to the client. So this is pretty neat. What you need to know is that when you write your code like this, you'll basically create a tailable cursor each and every time a consumer basically hits the endpoint. So if I open up another, so this would be, let me just increase the size, http /8080/stream. Then you see down here that we open up a new connection to the database, which isn't probably not quite what you want to do, because this again consumes resources. But what you might want to look for is to share your resource, that once a client connects and then another client connects, they basically just use the same connection to the database, because there is actually no need to open up another one, because just push it out to multiple endpoints and don't care about it. And you can, I still got time left. What you can do is basically a Flux allows to be shared, and there is a share method. There's a share. There's a share method that basically sets a threshold of 1. So basically what it does is it signals that the Flux must not be closed as long as there is at least one subscriber active. So if you open up a new connection, and as long as there's one active, the Flux won't get closed. Still, this wouldn't work as expected, because every time we hit the endpoint, we'd create a new shared Flux, but wouldn't subscribe to the very same Flux with multiple subscribers. So what you would have to do is you would have to have an instance variable, like let's say a Flux of, what has it been, person, and that is defined as, let's call it X, and then you would have to do something like repository find all stuff. This wouldn't harm at all. You can do that because nothing would happen until you subscribe to it, because this is just the definition of something. And then you would have, of course, to have something like share down there, and then at this point return this one. So this would basically do what you want it to do, though it looks a little bit weird having a Flux as an instance variable. Yeah. Good. A few minutes left. Let me just quickly show you router functions, because this is interesting. Git.co and Git.co. For those of you who like to dive into more, who want to more dive into the reactive and functional programming world, those of you might not like the declarative stuff with the REST controller. So in Spring 5, you can define router functions instead of your actual controllers. So what you would have to do is you would have to create the bean of returning router functions, and then you can go on and start adding routes. So what I've done here is basically I converted all the methods within the REST controller and all the get mappings to router functions. So I would say, okay, I have a route here for a get predicate that calls Flux persons on a request handler. And the request handler I've built basically returns a mono of a server response, and the server response is okay, and I put in the body, which is exactly just the call to the repository method taking a query parameter and wrapping stuff up as a person. And this still returns a Flux. Can I please jump there? This still returns a Flux. So this is just a different way of expressing the functionality. You can even combine the two approaches, so you could have the classic REST controller in there and combine it with router functions. I'm not actually sure if you really want to do it that way, but it works. And for RxJava types, it's a little bit different. This is something I also wanted to show you, because with the router functions, you can only in the body have a Flux or a mono. And in this case, you have to wrap the result, because this is returning an observable. You have to wrap it into a publisher adapter. So this is basically a component that just wraps it to another type so that you can use it with the router function, but this only applies if you choose to opt in into the RxJava world. And of course, you have this very same, you can do the very same stuff for the event streams by just setting the content type to a text event stream and then just start emitting a continuous stream of elements. And one last thing, then I'm done. I promise. 5 minutes. Is I wanted to show you how you can consume such a service from your Java application, because you've seen you can do it through command line and the browser. There is a component in Spring 5 that's called a web client. So you basically give it an endpoint, you create the web client in first place, and then you call, say, client.get, give it a URI, retrieve, tell it how to convert the result. So basically call body to flux, and then you could do something with it. In this case, I would just print it to the console. And if I've started that stuff over here, so we're starting currently with the router functions, which does the very same stuff. Down here, starting emitting, and we switch over. No! We switch over here and run this application. It should start it up, take the web client, go there to the endpoint, connect, and then just print the result and be done with it. Perfect. So this was a quick demo of what you can actually do. There's much more. There's many more convenience functions on Reactor, Flux, and Mono to explore. The web client is way more capable than I was able to show during this presentation. One last thing I want to give you on the way is that reactive and the whole reactive programming approach is about efficient resource usage. It's not about speed. So if you actually start comparing driver benchmarks, then you will encounter that for the same amount of data, it may happen that the reactive driver is slower than the imperative one. But it's about the efficient resource usage, because you can get more throughput with less amount of threads or memory consumption, because you just pass things throughout the chain. And though it's very easy, especially with Spring and the whole ecosystem projects, to create reactive applications, there is a price to pay, and the price is complexity. And you will feel the pain once you have an error in your chain and you have to debug that stuff, because that is really no piece of cake. So be aware of it. There is several threads included. There is deferred execution. The stack traces look quite different, and so make sure that you opt into the reactive world when you really have a need to do so, but just do it because you can. This doesn't make any sense. Yeah, that's all from my side. There is a bunch of presentations on Spring and Reactive at JavaDay 2017. So there's the one I already mentioned, Spring Boot 2.0, Stefan. There's Spencer Gibb about API gateways, Simon on Mythbusters with Reactor, and so on and so forth. Make sure to check those out if you're interested in a more deeper dive into that topic. And otherwise, I guess I have 1 minute for questions, or just come by later. There's one in the back, please.
Hey, thanks for the talk. The question is it possible to expose Flux as a WebSocket and to write a Java client which consumes the WebSocket and makes a Flux for me? Do you have such feature out of the box?
Yeah, definitely. That works out of the box. No problem at all.
Thanks.
Sure. Welcome. Yeah, otherwise, thanks for listening and enjoy your lunch.